In this grade 11 CAPS Mathematics video series, the focus will be on the first of two videos dealing with circle geometry. Let us consider the proof of the first theorem, namely that given any triangle ABC, then the sum of the three interior angles must be equal to 180 degrees. Now, if we consider this particular sketch here, we are given any triangle ABC, and the aim is to prove that the sum of the three interior angles of this particular triangle is equal to 180 degrees. Often it is necessary to make some construction. So what we're going to do here is we're going to draw line segment BD such that C is an element or lies on this line segment. We focus now on the following investigation. Here we want to investigate the statement that the segment from the center of a circle and perpendicular to a chord bisects the chord. So we are given a circle with center O, a chord, the line segment AB as a chord, and furthermore line segment OM perpendicular to line segment AB. We now investigate special cases to show that AM is equal to BM. In other words, to show by investigation that M really is the center of the chord, or this perpendicular. M is always the midpoint, right, of the chord AB. So therefore the perpendicular bisects the chord. So we can carry out many more investigations with GeoGebra. So we make the suggested conclusion, namely, given a circle with center as 1, 2, 3 and 4 as indicated here, then clearly in triangle AOB angles 1 and 2 must be equal, because AO and BO are both radii of the circle. Exterior angle of a triangle is equal to the sum of the two opposite interior angles. But because 1 is equal to 2, we can say that angle 1 plus angle 2 is twice angle 1, because I can replace angle 2 by angle 1. In a similar way, if we consider angle COD, we can say that angle COD is equal to angle 3 plus angle 4, again because OA is equal to 2OC. So 3 is equal to 4, so therefore I can replace angle 4 by 3, so I get twice angle 3. Putting these two results together, then we can say the central angle, BOC, which is clearly the sum of angle BOD and COD, but BOD is a sketch. Then here the chord is a diameter, and we can then conclude equal angles at points on the circle. So the two chords BC and DE will be equal in length if they subtend equal angles, equal inscribed angles, obviously, at points on the circle. We will discuss this proof as part of an exercise. The third corollary, very closely related here, but just the converse of this. If we know that the chords are equal, in other words, given equal chords, we know and furthermore we take into account that the sum of the angles of a triangle is 180 degrees. So therefore alpha is really 180 and 80 degrees, we consider the central angle to be 100 degrees. Here we consider the central angle and the inscribed angle in the major arc. But of course theta will be 30 degrees, because on the same chord HF they must have the same measure. Furthermore, angle CE is alternately equal to angle C, and we know from the first result that angle C is equal to 33 degrees, because it was given to us that JH is parallel to GF. And then we can say that angle D must be equal to angle E, because they are angles on the same chord JG, and therefore must be equal to 33 degrees. Let us look at a suggested solution to the last rise, so we can then calculate H to be 42 degrees. Once we know that H is 42, we can say that G must also be 42, because they are angles on the same chord MN. And then we can conclude that J must be 49. We have come to the end of the first video on circle geometry. Remember, the idea here was just to put the basics in place. You need to consult textbooks for additional example. You need to attempt as many as possible other similar examples on your own, and then compare your methods with those that were discussed in this video. Repeat this procedure until you are confident. Do not forget, practice makes perfect. Goodbye and good luck.